Hello everyone, welcome to the 20th session on deep learning basics and Spark deep learning pipelines. We have many friends attending: Kiran, Harun, Emma, Leela, Mukesh, Dinesh, Randra, Leela. Welcome everyone. Let's quickly greet each other. It's always great to see all of you. We are going to have a very good interaction today on deep learning basics. We've been interacting on this, but still I believe the basics haven't fully settled in the mind. So that's where I want to take time to brush up your basics and take you forward. These are very important concepts. First, let me make sure you can able to hear me. Harun, my friend, welcome. You're doing great on big data engineering. You're empowering them. I truly appreciate and all that knowledge you impart to our team will benefit everyone and you. It strengthen the concepts and it strengthen collaborative relationship with the team. Welcome, Harun. How are you doing today?
Thanks, Srini. I'm doing good. How are you?
I'm doing great for seeing you and our friends.
Yeah, thanks.
You want to greet our friends?
Hi, guys. Hi, everyone. I spoke to Leela yesterday, actually.
Uh-huh.
Yeah. So we are collaborating offline
Okay.
for basic issues. And Narayana also published that he was able to fix all the installation issues.
Amazing, man. Amazing. You're doing awesome. Keep it up.
Right.
Very good. We have Hema from Virginia. She's a very good friend of mine and Harun. She worked in Apple and she now finally reached to Virginia near North Carolina, near to her friend Harun. Great. Finally, she's with us and I appreciate Hema for doing great in the she's moderating very well and she has a lot of clarity on the both concepts, machine learning concepts at the same time, big data engineering. She has strong background in Java, so she constantly track the API. I appreciate Hema for guiding the team to quickly, without worrying much, look to the API and look what the parameters it takes. All these things takes time to get because API is like an ocean, but wherever is needed, looking like a dictionary. So you've been encouraging the team very well, and that would really benefit you as a leader wherever you go, whenever your company. It's always when you're able to share your knowledge. So that is where magic happens. So, Hema, keep it up. So, how are you doing today?
Thank you, Srini. I'm good. Hi, all. Good morning. Good evening.
Excellent. Excellent. Welcome. We have Kiran from New Jersey, very passionate about this stuff. She's excited. We exchanged the messages about this stuff, machine learning. She really got excited about this, and she's going to participate in the seminars. And I encourage that. Kiran, keep it up. I am very, very confident these concepts, whatever you are learning, are not just like another skill. I want to highlight this again. They will touch everyone. Even some of my friends who talked about this 2 years back and thought they don't need to learn and they're focusing on different areas, but in their company Their managers and bosses told them, our team cannot survive without these skills. So that is what they told. So they are now coming back to me. It's really 2 years back we discussed, but we thought they are not. They thought these are one of the choice, but it appears to be almost the choice in our company. Could you please help me? This is how the people are coming. So I see very clearly this is a great path, and not just for job. So job is going to be strong for everyone, but these are very, very powerful tools with which you can express yourself. You can gain career progress. You can gain good recognition. You can gain good career, what you call career path and compensation. And on top of it, they involve beautiful mathematics, which are coded by a very intelligent people, given us the libraries. We are just utilizing those libraries without losing the basics. We still try to understand at least the needed math. So math is wonderful, especially your cousins, your kids, or your brothers. They may be in the high schools or colleges, so you can help them. And for that matter, you can help everywhere, because a lot of places, especially nowadays, the basics on mathematics is very poor. And basics on mathematics is poor, there will be a lot of problems. They can't comprehend a lot of things in the world. So a lot of systems are designed with a lot of abstraction. So those systems can deceive the people. We may be simply get excited and get into the systems designed by people, which are very abstract. But mathematics helps you to understand the abstraction. Mathematics helps you to understand what is going on in economic world, in the monetary world. Because whatever we do, at the end of the day, it has to be sustainable. You want to buy a home, you want to invest in stocks, you want to move to one country to another, leaving your family. You want to build a good future for them. So you'll be working hard to save money. So you have to invest somewhere, otherwise they won't grow. So all these things, then you look after real estate, you look after stocks, you look after growing your salary, all these things. So you look after in a economic basis. So you look after the systems. These systems are designed. You need to, the mathematics and this machine learning helps you even to understand how these systems are designed, how they are targeting you through advertisements. So when they are targeting, how they are recommending, are whoever recommending these using machine learning, are these good people who are recommending these things? Are these helpful to me to buy in? Or am I just investing just because I got excited by or told by someone? So all these things really, really help you. So you are designing machine learning systems. So in the process, you also learn. Your brain is so powerful. So on which these artificial neural networks, the deep learning concepts are built. Machine learnings are great. Machine learning is good and great to solve many problems in the enterprise. But enterprise is also adopting deep learning, where machine learning techniques can't solve their problems. So these deep learning problems have been there for quite a long time in the industry, in the university, in the research. They are adopted by internet companies like Google, Amazon, different companies, Microsoft, Apple. And now these techniques are also getting adopted by the enterprises, Best Buy, different companies, retails, Walmart, all enterprises, Verizon, and different companies are adopting. So these enterprises also adopting these deep learning techniques. They're not very mature. When you go to a company, most of the 90% of the time you will only see the machine learning on top of big data engineering. They may be just picking up the deep learning. That's okay. So your basics, wherever you go, will help. So I want to make sure you really understand what is going on. Before you learn the details, I want to make sure you understand the high level, what are these techniques, how these neural networks are built, what is this weighted sum, how this function transforms a weighted sum into a probability, how eventually it leads to our classification. You need to clearly understand. Not only understand, articulate. That is where I encourage you. Already people are showing examples. Hema presented, Sairam presented, Leela presented, I think. Siva is going to present. Even they are going to repeat as well. So all this help you to articulate. Before you articulate, all this help you to prepare and settle in your mind. When the concepts are settled in your mind, you can able to express very well. Nothing else. Nothing else. Some people think it is English, it is I can't speak. All these things is not true. Don't believe. It is like a reservoir. If the reservoir is filled with water, if you open the gates, the water will just come out. So if you fill with your knowledge, if you have a good concepts, well settled, then you can be able to communicate very well. It is true with Harun, it is true with Hema, it's true with Nagesh and other friends. I encourage you to take inspiration. If I have to speak those things, I can talk hours and hours. You just sit with me, non-stop. Even I can take session for 10 hours. I can do it. But it doesn't help you. It doesn't help you. It doesn't inspire you. You may be thinking, oh, maybe Sini is exceptional doing it. I don't want that. That doesn't help you. I want you to, we can take inspiration better if our own friends do it. Oh, Harun is doing it. Oh, okay. I feel good. If Harun can do, then I may be able to do. Oh, Hema, my classmate is doing it so well. Oh man, if I practice, I can do it. Leela started presenting. She has some challenges, but still she is trying and presenting it good. Well, let me also try. So that inspiration comes when our friends start articulating it. So that's why I'm encouraging. So I want everyone to take this seriously, being there and presenting it. Because when you go to different teams, machine learning teams, deep learning teams, you have to articulate. Only when you articulate, they know how much you know. So that's important, everyone. So I encourage everyone. Kiran is also ready in the coming weeks. I'll share a schedule. Kiran and team already. Siva will have something with Mukesh this week and tomorrow. I'm not sure if they already started discussing with Kiran. So how are you, Kiran? I think welcome. You want to greet our friends?
Thanks, Srini. Hello, everyone. We haven't actually gotten together. I did discuss with Siva, so hopefully we should have something by tomorrow.
No problem. You can reach me, Siva and Mukesh. You guys can reach me. Anyway, we are going to use the same data set, so most of the big data engineering stuff is taken care. Only thing is you guys are going to use linear.
Right.
Awesome. No problem. So next we have, okay, I'm muting, so I see some background. Next we have Leela. Leela, welcome. I think you started presenting, taking help from Hema and your team Sairam. I truly encourage you, appreciate you, catch up with the team, and also good you are discussing with Harun. You're in good hands. That would strengthen your learning, because you might come from background where these things, analytics, may be new to you, but I encourage you all, you and everyone, the analytics and data is the way. And big data is going to be very big. So in future, even they won't be saying big data, because all data is going to be big. So it's all data driven, data stuff. Even your friends, your cousins, your kids, everyone may be working in this area in a differently. It may not be the same as we do, but it's different. It's a field that is getting evolved. So don't think, hey, you are already late. No, actually, these things appear to be being talked for a while, but what you are seeing is only the beginning. So there are a lot of which are next to 10 years, also 20 years, you can work in this. Leela, welcome. How are you doing today? You want to greet our friends?
Actually, I'm good today. Hi all.
Excellent, welcome. So Mukesh Narayana. Mukesh, you are working with Siva, I know. Welcome. You have good analytics background. Keep it up. This will definitely take to the next level. Please continue to collaborate with Siva and Kiran, and we'll be looking forward for your participation. So how are you doing today? You want to greet our friends?
Hi, Srini. I'm good. How are you all? I'm interacting with Shiva.
Excellent.
We've been in touch.
Very good.
We'll definitely talk with Kiran too.
No, wonderful. So it's only beginning. Even if you just present a level 1, you will still have multiple opportunities to focus, but increase the traction. Welcome. So we have my friend, always feel great to see. It's Nagesh. Nagesh, welcome. I think you came on a right day. We're going to discuss this deep learning neural network. We already started discussing a few basics, but still I didn't feel good that our team got a good sense of it, everyone. Few people have got it, but some people have forgot it. So even today, I want to go a little bit deep so that the learning will be deep. So welcome. You always contributed in the Cassandra area and many area, and very ever ready to present a lot of good stuff. So I want you to team up with Harun and to empower our team in the process to establish your strength in your leadership. Welcome, Nagesh. How are you doing today? You want to greet our friends?
Yes. Hi, everybody. Thank you, Srini. Sorry, of late, I've been missing 2 or 3 sessions, but the next Tuesday, I'll be finishing my son's computer science exam.
Oh,
so I'll be free after that. So I'm still busy with my family.
Oh, wonderful.
Yeah, I'll definitely hook up with Harun, and I will talk to him offline, and we'll come up something on this. This is great, interesting. I don't want to miss this but I have to make some backups in the house. So
no problem. Family is always important. In a way,
yeah.
if you know, we've been discussing a lot of things. Now your son is very young, still he is learning computer science subject. So
Yeah.
which grade he is?
He's in the 10th grade.
He's
So
10th grade. Trust me, now within 2 years in the college, immediately in the first and second year itself, they'll be learning all this stuff. It's an opportunity for you, really. Now all universities starting undergraduates in Bachelor of Science in Data Science. So within 4 years, at least 50% of colleges will have undergrad in data science. Now the 2 years, most of the colleges will have masters in data science. So what they do is things. So in a way you can help your kid. So
yeah. Thank you very much. Yeah, this is very interesting. As somebody said, Kiran or somebody, this is very interesting compared to data engineering. Of course, data engineering is the foundation you need, but this is more interesting.
Right. Excellent. So we have Narayan Rao from India, IIT Delhi, IIT Madras. Sorry. So he's collaborating with us. He has some speech challenges. He's medically, but he is almost overcome after interacting with you. So I want you to be aware of that and collaborate with him and encourage him. But he is very good. He is a 100% mathematics guy. He's from IIT Madras. He is trying to participate with us, and he is learning these techniques. It's good. Welcome, Narayan Rao from India. How are you doing today?
Hi, Srini. I'm doing good. Hello, everyone.
You want to greet our friends?
Yes. Hello, everyone. How are you doing?
Okay, great. Welcome. Okay. So we have again Surya, a friend in Apple, and who came back to US. And welcome, Surya. He is interacting with Harish. Harish has given very good presentation, I heard, and recommendations. So I want him to interact more. You need to bring your Kishore also into the picture more by motivating him. You have a lot of issues at home. Welcome, Surya. How are you doing today? You want to greet our friends?
Yeah. Hi, Srini. Good morning, and good morning to all.
Excellent. Welcome. So hope I haven't missed anyone. We have, okay. So once in a while, it always helps to greet our friends. So everyone, welcome again. So let's get into, guys. So we have today, let's spend 2 to 2.5 hours in between a break. First, to try to understand at least an hour, try to understand these deep learning basics. Then I'm going to introduce to you Python and also deep learning basics, deep learning pipelines. Deep learning pipelines is a Python library from Spark. It's a PySpark library, which runs on top of industry standard deep learning software called TensorFlow and Keras. I'll talk about that first. Let's get into deep learning basics. So for some people, they can quickly catch because we already discussed some, but I give a different perspective, few points, so that you will be very fluent to talk to others. I can bet you, if you can speak these concepts fluently with anyone, they truly appreciate you. Even someone who don't like you, if you talk these things, if they know its value, assuming they are working in some related area, they truly appreciate you. Okay, let's focus, guys. So as I mentioned in the last class, deep learning is based on the artificial neural networks. There are some problems in industry where the machine learning techniques, machine learning algorithms aren't able to solve. So that is where there used to be two techniques in the industry. That is, one is neural networks, artificial neural networks, and another is support vector machines. But over a period of time, universities and internet companies have found artificial neural networks are better suited for deep learning, not support vector machines. So that is where these artificial neural networks became a de facto standard for deep learning. So these deep learning solutions are the solutions to the problems where machine learning techniques can't do, especially the problems related to images. Of course, we have done, and I believe Hema has shown you, image recognition using decision tree. But for small number of images, it may be true, it may work. But if you have a lot of images, the efficient techniques, machine learning techniques are not efficient techniques. So that's why you really need very deep learning. So the machines are going to learn very deeply. So what is this exactly? What is really happening? The learning. You already understood. In the machine learning, the learning means, in the case of decision tree, the learning means building a decision tree. The random forest, building multiple decision trees. In the case of linear regression, finding the weights. Learning means really you are building y is equal to mx plus c equation. So where you are finding m. In the case of recommendation, it is learning to find out the ratings using matrix multiplication. In the K means it does the iterations to build the clusters. That is the learning. So the learning is based on the algorithm. And that algorithm works on the data in the hand, training data. And you get a model. That model captures the intelligence. The model captures that intelligence. There are a lot of discussions. They're very comfortable with it. So when you say deep learning, the neural network that you build learns and create a model out of it. So that model has the learning, the model has, when it is learned, the model has a workable weights. So when you say a neural network learn, it means it knows its weights so that it can solve some problem. So let me distill a little more. So neural networks are built after the brain. Your brain has a neurons. These are neurons. These are different neurons. These neurons are connected. So when there are connected neurons, they are called neural network. So we are talking about artificial neural network. Artificial neural network means they're taking the concept of brain neural network and putting in a computer. So building a neural network to solve a problem. So what problems it solves, we'll understand. How these neural networks looks like, what exactly happening. You need to have clarity. Not only you need to have clarity, you need to be able to articulate. When you articulate this, people truly appreciate it. People truly appreciate it because these are the things people are talking in the top universities, MIT, Stanford, Harvard, Google, Facebook, Microsoft. Wherever you go to the top places, these are the things people are talking about. At least if you can ask a question on this, at least you can understand what they are saying. If you can do a conversation with them, or if you can help the coming generation. or your own knowledge will help you in your job. So the neural networks looks like this. A neural networks always has an input layer which takes the inputs. The inputs may be from the features or the pixels from an image. So an image will have pixels 28 by 28, or if it is a colored images, it may have a different pixels. So anyway, whatever that rectangular grid, 28 by 28, or whatever the m into n, you can imagine it as a linear. All the pixels, put it as a 1, 2, 3, 4, 5, all the pixels, put it as a inputs. Each node is 1 pixel. So if this is an image, the network also has output. Output is a category of that image. Category of that image means if you take a numbers, if the input is a numbers, pixels of numbers, handwritten numbers. Hema may write 8 on the check. Nagesh may write a different 8. It is same 8, but the way Hema writes is different. The way Nagesh writes 8 is different. But slightly different. Our brain quickly recognizes whether Nagesh writes or Hema writes. We know it's 8, but it is not exactly 8 because it's a handwritten 8. It's not a computer printed 8. It's slightly different, but you know it is 8. So these are the numbers, assume. So maybe 100 people, 1,000 people, different people write in 8 in a different way. So, but whatever 8 you put here, the output means image recognition. It is recognizing. Output should be show as a 8. So it means here this is the categorization. Basically, here these are the numbers. Here you need to have categorization. So you may get thousands of numbers. Thousands of numbers. I'm talking about only 1 to 9, rather 0 to 9, which are 10 numbers only. But you may have thousands of images because it came from different people, multiple people. We're not talking about 1,000 numbers, because even if it is 1,000, 1000, even though it is 1,000, it is only 1 and 0. Even it is 1,500, it is 1500, only 3 numbers. That's what I mean. If your system can recognize 0 to 9, it can recognize any number because you can go one by one. So the problem we are saying is input is numbers with pixels. The output is their classification. You need to classify whether it is 0 or 1, 2, 3. Of course, we need to have 10 classifications. So that is the problem. If I put 8, this should glow. All this should be dim. Imagine these are bulbs. 1, 2, 3, 4. You put 1, this should glow. This will become dark. You put 2, this should glow. This other bulb should be dark. You put this should glow. If you put 4, this should glow. This should be dark. That's what I mean, classification. Either this or this, either this or this or this or this. If it is this, this is no. If this is yes. That is the idea. But how, if I put a number, how it immediately recognizes? That is the question. So for that, you are building a network which has that intelligence. So if you have given input, you should get the desired output. Desired output. Kiran, does that make sense? At least as for the problem we are trying to solve?
Yes, Srini.
Very good. Excellent. So a neural network will have in a simple sense, you'll have inputs, you'll have outputs, but there will be a connections because this inputs has to come here. The input has to come here. There should be a connections. So these are connected. So when you're connecting, you will have a hidden layer also. Not only input and output, there will be a layers. This is a hidden layer. In a deep neural network, if you have more hidden layers, it is called deep neural network. Layer 1, layer 2, layer 2, layer 3. So it's a deep. That's why it is a deep. You still have input and output. These are the only one input and one output. But in between, there are hidden layers. So these are that's why it is called deep. So we'll understand why these are needed. Let's see. This is modeled after the brain. Our brain works like this. This is neuron. Imagine it is a node. It is like a node. And other nodes. These are well connected. This is how our brain is. Let me go. This is how our brain works in high level. So your brain is as a billions of neurons. Billions of neurons, your brain. Some neurons may die. It's not a big deal. When you're born, you'll have some billion neurons. They will grow to maybe 1.5 billion. Those are neurons. But after that, when we are becoming old, some of the neurons die. That's okay. We have so many neurons. Not only do we have neurons, we have neural network. These neurons are connected. Look here, they are connected. See, like this is one neuron, this is another neuron. These neurons got connected. And even see, take this neuron is connected to this neuron, and even this neuron may be connected to another neuron. This neuron is connected to this neuron is connected to this. A typical neuron looks like this. This is how, this is one neuron. This is one neuron. A neuron will have a cell body. This is the node. You can think it as a node. Emma? This node has a dendrites. These are the dendrites. You can other neurons can communicate with these dendrites. You want to communicate with this. If you want to send some inputs, it goes. When a human being sees something, it's a network flow of the electrical flow of the information between these neurons. So this neuron has a node. This is a cell body. These are the dendrites with which other neurons can communicate. Okay, look here. So input will come to this way, to this neuron. One input, second input, third input, fourth input, fifth input, sixth. A lot of inputs can come to this neuron. And this neuron will have also output. The output will go like this to this cell. So this is called axon, actually. This is called axon. The output. This axon has a different layers. Layer in the sense, it's called myelin sheath. This is used for memory. See, some of you, of course I do. Sometimes I lock the door, and after I go out, after some time, oh, I don't know whether I locked the door or not. Some of you close the garage. Nagesh, I think I can associate with you. You close the garage. You don't know whether you close the garage after you're driving. Oh, man, I don't know if I close the garage.
Yeah. I mean, that's true.
Okay. So
Always happens.
Yeah. So this is the cause. This myelin sheath. This myelin sheath, if it is strong, you remember things. It's getting a little bit weak, then that's where you start forgetfulness comes. Also, not only just age. If you are doing too much information, too much Facebook, too much text, too much parallel tasking, too many tasks with kids, husband, wife, who are calling you constantly, and you have too much work, this becomes a little bit, the communication between this will not be smooth. So this myelin sheath will become a little bit rough. So the output has to go to another neuron here, and it goes connect to another neurons. So this axon will connect. Again, axon connect to the other dendrites. These are the dendrites. Simply see, these are dendrites. Dendrites of another neuron. This is how it communicates. When it communicates, the place where it communicates is, this is the place. This is axon. These are the dendrites. In between, there is a communication. It's called synapse. It's called synapse. These are the electrical pulses. Electrical pulses. Electrical pulses. So that pulses have the signals. Electrical pulses have electric signals. So what is the weight? What is the voltage with which it fires? Is depends upon what is happening in your brain. So if you see, even if you don't see my face, your brain immediately when someone is talking, you know, hey, that is Hema talking, hey, that is Leela talking, that is Harun talking. This is, then no, hey, who is that talking? Sometimes we ask, you know, we don't know. Our brain cannot, the weights are not correct. Who is talking that? Or then say Mukesh, say, yeah, this is Mukesh. I saw Hema was asking, hey, who was talking? So Hari was saying, Hema, this is Hari. Oh, okay, I know. Now next time Hema remembers. So our brain, the synapse, when it fires the weights that can recognize the voices, images. When you see someone after 10 years, who is this? I saw this guy somewhere. Oh, then slowly these neurons started firing. After some time, okay, you get, oh man, Nagesh. Oh, you're Nagesh, my colleague. I remember you, you say. Somebody will come, hey, are you Nagesh? Who are you? Nagesh might ask. Hey man, Nagesh, your classmates. We used to sit in the first bench. You used to sit in the first bench, I used to sit in the back bench. Oh, you are sitting in the back, that's why I don't remember. Anyway, something like that. You know, some story always will be there. So this is what the communication happens. So this is called synapse. So in summary, a neural network has a nodes, multiple nodes. So multiple nodes will be connected to multiple neurons, though I shown you only one. You see here? You see here? They are got connected. A multiple combination. In between, they communicate with weights. If weights are strong, you remember things, you recognize the things, you recognize people, you recognize voice. You recognize the things very quickly. When you attend this class, you learn deep learning or machine learning. So when you learn one time, your synapse is getting stronger. The signals are getting stronger. When you present to a class, you prepare, and your signals are more stronger. Your weights are more stronger, more accurate. When you practice, what happens is this communication becomes smooth, and this myelin sheath will be growing. The brain is like a plastic brain. That's why it's called plasticity, brain plasticity. Your brain is not constant. Whatever your age, whatever your background, you can learn anything if you can train your brain properly. When you're training your brain properly means you are improving the myelin sheath and also the dendrites, the synapse communication between these neurons. As you age, some of your neurons might die, but it doesn't matter. You have billions of neurons. Billions of neurons connected together. There are more than trillion connections in our brain. Trillion connections, more than trillion connections, because each neuron can connect to multiple neurons. So this is how the brain works. That's why you quickly, when you see something is moving, you might think it is snake, but immediately recognize that it's not snake. Everything happens instantly. So when something is happening, what is happening is your communication is passing through multiple layers. This neuron. Then finally, you recognize. You have receptors, neuron receptors. Then you'll be able to recognize. So you'll have always an input, you get an output. The input and output. So when you see something, even from the far, maybe who is coming? Maybe I think it is Surya and Shiva coming. You see like a fuzzy. But after some time when they're closing, So during that process, your brain neurons are firing. When you see them accurately, no, I'm pretty sure they are there. So you got your output. So these are the techniques that were borrowed into the artificial neural networks. That's why it's called artificial neural network. So what artificial neural networks is the mimic of this brain, but in a computationally mathematical. So look here. In artificial neural networks, the whole idea is take the inputs, give the right outputs. That is the whole idea. As I told you, even our brain also, take the inputs of our classmates whom we met 10 years back, it may not be able to recognize. I don't know, some people, I don't know if they have experience or not. Nagesh, you had to comment. Have you ever, whatever the dress they are, have you ever seen a female and you thought it's male? Or you saw a male, you thought a female? Or someone?
Yeah. It's I think nowadays it's common. I'm sorry.
Nowadays, okay. Yeah. So sometimes it happens depending on the dress, because so your brain
right.
that whoever wears some pant, male. Even you not some facial, the way you look, that side, they may have a feminine or male face. Okay. So what happens is you got an input, your output you couldn't classify correctly, right? That is a problem, right? There at that moment. That's correct. So even though we are human beings, we ourselves take the inputs, can't classify. That is what we are doing, a male or female. That is what the decision is there. Or a known person or unknown person. So something like that. So you just exactly. So you have input, you need to classify to write output. That is how the problem is. You have image, you want to classify, it is a 1 or 0 or some number, classification problem. So most of the neural networks are classification problems, complex classification problems. Of course, they can also be used for the regression and some recommendations, etc. But mainly this classification problems. So let's understand. So a typical artificial neural networks will have inputs. Input layer, this one. This is the output. I have a two classifications. As I told you, brain also have a multiple neurons before you recognize the image. You'll have at least one hidden layer. This is a basic neural network. If you have more hidden layers, it is a deep neural networks. You will understand the advantage of having more after a few minutes. First of all, take this one. So as I told you, imagine this is anyway input. So keep it like that. Now this is the hidden layer. This is a neuron, a neuron, of course, artificial neuron. As I told you, you can imagine this is connected to every neuron. It means this is connected to this is connected to this is connected to this. Of course, it is possible sometimes this may not be connected. Because in our brain also, every neuron won't connect to every neuron. But assume here, because we are not depicting billion, we're just doing 3. These 3 are connected here. If it's not connected, this is cut, that's it. Assume first it is connected. So the connections, when you say connections will have affinity. Affinity means, see, suppose take this example. I am Harun. I am connected to Harun. Harun and I have affinity. Harun, how long we know? 6 years, 7 years. Take Hema, first 5-6 years. Like that, take Nagesh, last 3 years. So the affinity is a quantifiable affinity. If the electrons are flowing here, it may be voltage, it may be electron volts. So the weight is always, any connections will have weightage, mathematical. So this is what, if you have a connection, if there is no connection means this, you can think it as a zero weight. Zero weight means, even though you connected, there is no use. Zero weight means nothing is going on here. Nothing is going on between these two. So each node here is connected to this. So then what is happening into this neuron? Take this neuron also. This neuron also is connected here, connected here, connected here. This neuron also connected here, connected here, connected here. So every connections have its own weight. Please observe, every connection has its own weight. Okay, sometimes it may become equal, that is a different matter. But the basic understanding is they are different. So and they are their own unique connections. Now take this one, take one simple one. What is happening mathematically here? What is happening mathematically? Mathematically, what is happening? This is input. Assume this is X. This is M. It's MX. When you say you went to a McDonald's, you purchased a burger to you and your friend. The burger is, say, $2. You purchase 2. 2 is the weight. This 2, let me put $3 burger. 3 is the input, cost of each burger, which doesn't change. But what changes is how many you are buying. This is Leela buying 3 burgers or 2 burgers, one for her and one for her friend. So what is happening? This is 3 and 2, so becoming 6. Leela also purchased chips, not chips, French fries. These French fries, $1. Again, this time 3. Maybe her friend likes more French fries. So 3 into $1, $3. Lila also purchased juice. Her friend said, no, I don't want this one. Oh, okay. So tell me what is happening now. What is the amount Leela has to pay? Leela, tell me. This is $2 burger, $3 burger, 2. 3 into 2, $6. This is French fries, 2 into 1, $2. 6 plus 2, $8. And 1 juice, $2. So 1 into 2, 8 and 2, $10. So this is the weighted sum. This is Hema. Hema also the same story. You can't avoid McDonald's. At least once in a while. One for her kid and for her baby, one for her friend, for herself. The different combination weighted sum, $10 or $12. This is different. So each customer, these prices won't change. The burger value, the price doesn't change for anyone. But what changes is weight. Depending on the weight, weighted sum changes. Weighted sum changes. So this is a number now. This is a number. Now this is assume Leela it is $10, Hema it is $12, and somebody, and Nagesh, it is $11, whatever it is. Now again you see, look here, this is output Asian. Still it has a weight. Now these are the inputs. Okay. This is output. This output is connected here, here, here. Again the same story. This will have weight. Of course, I don't have example here to say this is a weight. This is multiplication of weight into input. This is again weight. Multiplication of this input into weight. Multiplication of weight into this. That is how it goes. This is what it is shown here. Look here. These are the inputs. Each has weights. H1 has weights. 3 weights. H2 has weights. H3 has weights. So what is weighted sum? 1 into 1.5. See, look here. This is weighted sum. 1 into 0.5 minus 2.0 into 0.9. The weights can be negative also in the network. In the case of burgers, etc., need not be negative. See, this is the weighted sum. So whatever that is coming to H1 is a weighted sum. H2 also weighted sum. Its own weights and inputs. Its own weights and inputs. Weighted sum. So what is happening with this when you multiply the weighted sum? See here, minus 1.9. This weighted sum is 3.1. 0.5, this weighted sum is minus 0.4. This weighted sum can vary. The weighted sum can vary, just like the burger or the price Leela is paying, Hema is paying, and Nagesh is paying. So they do some normalization also in the networks. They pass these values to a beautiful function called sigmoid function. The sigmoid function do some kind of normalization. Whatever the value you pass to the sigmoid function, either it makes a 0 or 1. What does it mean? Look here. This is a function. say this is the function. Function sum of t. T means input, or you can think as x also. 1 by 1 plus e power minus t. Nagesh, can you recall this math? Or you check with your son. I'm pretty sure he can tell you. So what is happening? This function, this is a beautiful function. Whatever you pass t value, either you pass 100 or 1000 or minus 2000 or whatever is it, the output is always 0 and 1. 0 or anything between 1, either 0, 0.1, 0.5. So take example, pass 0. Let me see. My friend Hari is there. Hari, Harish, I think he has some work. Let me check with Siva. Hey, Siva, welcome. Siva, what happens if I put 0 here? If I put pass 0 to this function.
1 by 2, Srini.
Can you explain to the team why?
So e power 0 is 1 and 1 by 1 plus 1 is 1 by 2.
Okay, so if you pass t 0, so you are saying, Siva, is that correct? E power minus 0 means 0 only.
Yeah.
E power 0 is anything to the power of 0 is 1, right?
Yeah.
So you are saying 1 plus 1 is 2. So 1 by 2, which is a 0.5, right?
Correct.
Okay, so this is what you are doing. So this is a x. This is put a y coordinate. This is x coordinates. Y coordinate you are showing only from 0 up. This is positive x, positive y, positive x minus negative y, negative x. Sorry. So when x is 0 or t is 0, Siva told the output value is 0.5. Okay, this is the point. Then what happens? X is becoming positive. X is becoming a huge number. 2, 4, 6, 100, 1000. X is increasing almost infinite. Yeah, Siva, what is happening here?
The output value is approaching maximum value of 1.
How? Can you explain? Can you detail to our friends?
So if we substitute t with a positive value,
positive infinite, the huge number,
it becomes e power minus that value, e power negative value.
E power negative of huge number, right?
Yeah.
What happens? Anything to the power of negative, huge negative value is a 0.
Yeah.
Because if it is positive, it is infinite. Anything to the power of e power minus 100, e power minus 1000, e power this one, so that becomes a 0.
0, right.
So this, if this becomes 0, Siva is saying, if this 0, 1 plus 0 is 1, 1 by 1 is 1. So as t is becoming infinite or x is becoming infinite, your output value is the y-axis. It will become 1. So for in-between values, it will be in between. So the maximum upper bound is 1. Nagesh, this is a good equation to discuss with your son. Then what is happening, you see? Siva, what is happening when t is becoming negative?
So that e power becomes positive, like if we substitute minus 2, it will become e power 2.
That is good. So Siva is saying that the minus of minus, this is already minus t, minus of minus becomes positive. So this may become e power 2, e power 3, e power 5, e power 10, e power 100, e power 1000, e power infinite. Anything to the power of infinite, positive infinite is infinite. So this is becoming infinite. 1 plus infinite is infinite. Huge number. 1 by infinite is 0. 1 by infinite is 0. Infinite is simple. Anything plus or multiplication to it is infinite. 1 by infinite is 0. You all know. So 1 by this whole thing becomes, as it's negative, it becomes 0. So it means this beautiful function helps us to normalize, to handle this network very smooth and without losing its sanity. So anything you give it to us, it will give you a number between 0 and 1. So that is what is happening. This is called sigmoid function. So this is the weighted sum. This is weighted sum. You pass it to sigmoid function. The output will be, even if you pass negative, you got it. It should be between 0 and 1 only. 0 and 1 only. You see, you got the output here. So instead of negatives, large numbers, etc., it gave it beautifully between 0 and 1. So always this H1, H2, H3, the values will be between 0 and 1. Okay, this is the values we start. Again, here weighted sums are there. Even this has weights. So automatically, even these outputs will be between 0 and 1. Now imagine if this is 0 and this is 1. What I mean is the output values of 0 and 1. 1 means yes, 0 means no. So it's a classification problem. I'll talk about that more clearly. So you understood the basic neural network here. Same thing here. Here now, here weights. Now after the weights, this becomes like this. These are the inputs, these are the weights, this is the outputs. These output becomes inputs to O1. O1. So again the same story. See, O1 has a weights. O1 is connected to this, 3 weights. This is the weighted sum. Minus 3 into this, 1 into 9, 6. This one. This is the weighted sum. This is the weighted sum. The weighted sum is passed to the beautiful function, sigmoid function. Again, this O1, O2 values should be between 0 and 1. These are the 0.35 and 0.85. Even if you add some bias means, see, even if you add for this some 5 or 6, the output will be always between 0 and 1. Bias means, yeah, they add some, like, see, if you take y is equal to 5x or y is equal to mx, you will say even y is equal to mx plus c, some constant. Some bias says you can add into the system to tweak the system. So don't worry much about the bias. Bias is some just adding a number, but it doesn't affect. It's just a little bit, again, additional normalization, but the output will be always between 0 and 1. That is how a typical neural network mimic the brain, take the inputs, uses the weights, uses the middle layer, hidden layers, eventually can reach an output here, Now, if you see here, so these are my inputs, these are my outputs, 0.35 and 0.85. This is the O1. O1 is 0.35, O2 is 0.85. Assume these are probabilities, 0.35, 0.85. So this is more stronger, right? Nagesh, if you see, this is 0.85, Siva. This is 0.85 and 0.35. This is 0.35 and this is 0.85. It means which is stronger in these two? This one, right? Of course, they put it wrong. It's not O2. This is the O2. This is stronger, right, Siva?
Yes,
output
0.85.
So if you put a bulb here, assuming the rule of the bulb is which the greatest one bulb will glow. Which bulb will glow?
O2.
O2, right? Now imagine these are just 2 classifications. Imagine you have more classifications. They're like numbers. Here. These are the numbers. These are the numbers. When you put these numbers also, there are 784 pixels. These are grayscale images. an image, Nagesh, an image will have pixels. This is 28 by 28, grayscale. So the bright one activation is 1.0. Something is not, it is 0.0. In between, some grayscale, 0.7. It's always between 0 and 1. So these are the matrix type. Now linearize it. Linearize it means write continuously. 28 by 28. Take in a vertical line format. So each one is a pixel. Each one is a pixel, just like here. It's a rectangular pixels. So each one is, this is 0, 0.0, 0, 0.0, 0, 0.0. There could be there could be a lot of zeros. 0.0, somewhere 1. So these are the inputs. These are the inputs. The output, see what? Output has a category of 0 and 9. 0 and 9. If you put here, the expectation, the desired output, if I put 9, this bulb should glow. If I put 8, the desired output is 8. If I put 7, the desired output 7. So those are the desired. What does it mean by desired? Last time Kiran asked, I think we talked about expected. She said, hey, what is expected? I think desired is the right word. Kiran, is that correct? Desired output.
Yes, Srini. Yes, because it's based on the data that's known to us. So we are kind of initially training the system. So we know the values from before and we have the set of values that we are expecting.
That is correct. We're expecting a desired output. So this is the desired output. Okay, very good. So, but what does it mean by desired output? Means this bulb is glowing. But how this bulb is glowing? This bulb is glowing based on the maximum value. See, these are the categories. Does it mean, see what? This bulb is glowing means, does it become the output value here does it become 9? If this is 5 means, this bulb is glowing means, does this value becomes 5? No, right? The output is always between 0 and 1, right? So what does it mean when this bulb glows? It means this has a maximum value, right? Like this, look at. So this is 0, even this is 0.1, this is 0.1. Maybe 8 is 0.9, this is 0.911, right? Forget about this. So if I have these outputs for these categories, don't you think this is the bulb, this is the maximum value, see what? So this bulb is glowing, right?
Right.
So try to understand that point. Here does not mean the output value is 9. No, this is a categorization. Classifications of 0th classification, 1st classification, 2nd classification, 3rd classification, 4th classification. If I put 4, these 4 bulb glow. It means the output value at this node is greater than all the outputs. The ideal is this output value should be 1, all others should be 0. The ideally. If these are all 0 output and the 4th has a 1 output, this is perfect recognition. So now imagine you have so many 9s. Now see, okay, you got it. So these are the inputs, these are the outputs, these are the desired outputs. But where is the control? Go back. Where is the control? These are fixed. This is desired. So I want this to come. For this, I want this. What is influencing these output values? Hema, what is influencing? These are the inputs. I want this to be large. Or Siva said, I want this to be large now, not this. This became large, but assume we know I am desiring this. Assume I am desiring this. I want this to be large. So where is your control? Emma, you're on mute. Let me ask. Shiva?
Weights, Srini.
Very good. So these weights, see, this is this is $12 for Leela. This is $13 for Hema. This is $11 for our friend Nagesh. So how you can change this value? Leela, tell me, these burger values are fixed. These $12 or $15 each is changed based on how much you are buying, right?
Yes.
So those are weights. So Shiva is absolutely right. So what is the output desirability, the variation in the output has the controls only in the weights. So now to sum up, very simple. Now come back, guys. Inputs are fixed. Outputs are desired. Anything you want to change your desirability, the control is only on the weights. On the weights. Then you ask me why we need to change the weights. Look here. Now let's go here. Let me jump to few slides a little bit and come back. Okay. Our understanding, can we imagine this? Shiva, I just tilted. This is the input. So this is the letters this time. These are the letters. A, B, C, D, E, F, G, H, I, J, K, Q. Okay. Letters are numbers, whatever it is, including letters. So you have A, B, C, D, E, F category. How many categorizations? How many numbers will be there? Like 26 letters. Then numbers 0 to 9, which is 10 numbers. Right, Shiva?
Right, Srini.
These are the pixels. Imagine this is a hidden network. So this is what the expectation. If you put Q, the bulb should glow here, Q. If you put A should glow, right?
Correct.
But what happens? Let me go back and come back. What happens? Now the same thing. Look here. This is the layer 1, layer 0. These are the inputs. This is the outputs. When I give inputs, when we have output, what if this bulb didn't glow? Let me go back. I put Q. This bulb didn't glow. Instead, this bulb blew. What? Doesn't mean, it means that is not desirable, right?
Right.
See, I gave Q. This became a maximum value, not this. Then don't you think there is an error? Don't you think you need to change the weights?
Correct.
It means your system is unable to recognize Q. This should glow. This should not glow. Then you will change the weights. Okay, it blew. It has some set of weights. Now you put another letter. You put A. C glue. Don't you think you will change the weights again?
Yes, yes, Srini.
Now you change the weights. It recognizes C. But what happens? You trained for Q earlier. For Q, you changed the weight. It was working, but now you change. Now this time Q is not working. It's possible, right? It's like a typical software issue. In software also, you are trying to fix one problem. That problem is fixed, but you created another problem. Something working is not working. Does it happen? Hey, Suresh, sorry, Surya, has it happened any time for you? It's possible,
Yeah,
right?
yeah, it's possible, Srini.
It's possible. See, you have, your weights are good for Q. No, earlier a Q is not working. You changed these weights. Q is working now. Now for A, sorry, you put C, but the A bulb is glowing. So you change the weights now. Now C is what? Sorry, C is working. But you will do the regression test also, right? Again, you will see whether it is working for Q or not, right? Surya? So your
Yes,
regression failed. Your regression failed. That is what the regression is all about, right? Who is in the testing in our team? Who does testing, regression testing? Anyone? Surya, Siva, Leela, are you in testing? You do some testing also?
Yes, Srini.
So what is you do regression?
Yes.
So what exactly the regression means? What do you guys do? You even test the something working also, right?
Yes.
So
Regression we do to make sure not only the existing changes are there, but also the previous existing system, rest of the system is fine.
okay, exactly. That is very good. Good explanation. That's good. So Mukesh, what Mukesh is saying and what Leela is saying is, hey, we changed it, Q is working, and we changed for C. We need to make sure again Q is also working. So finally, you should adjust these changes such that it works for C, it works for Q. So this is a typical software change. You are changing many things. You should change, your change should not change what is working. So you change your system such that everything works. Exactly. So that is where the number of layers helps. So what is happening? Now see, so this is what exactly you learned. These are the inputs. For any neuron, there will be weights. So many. If you have two neurons here, this has its own weight, this has its own weights. Now if you have so many, if these are inputs, these are outputs, you have 16 neurons. Each one in this layer, each one has 784 weights because this connects to everyone. 1, 2, 3, 4, 7. You see it? 16 into 784 weights. Now again, this becomes inputs to another 16. So 16 into 16 weights here. 16 into 16. Again, this 16 becomes inputs to, these are the output classification, 0 to 10. 10 into 16 weights. And for each node, there could be some bias they can add. Even through bias also you can control. Bias also helps you to control. Bias means, you remember anyone go to, of course, nowadays everyone going to Walmart and grocery stores. You don't have weights. Anyone remember going to a traditional farmer's market where they put weights? They use the vegetables one side, weights another side. In India, sometimes you may not have 100 grams correctly. Then they put some small stone to adjust it. Anyone remember? Or am I the only one who went to vegetables?
Yes, I remember, Srini.
Oh, okay. Thanks, Kiran. So what is that? What they put a stone, small stone. Then they will tell that this stone is 12 grams or something. They will tell. So it's a bias. So they're introducing the bias to adjust the things. So the weights are adjusted. That is also the point. There itself we heard the weights. So imagine now, this is the inputs, this is the outputs. If I put 9, I should get 9, but every time I need not get the 9. I may have an error. To address that error, I'll adjust this. To address another error, I'll adjust it. To address another error, I'll adjust it. I need to adjust such that you totally, ultimately, it should recognize every image. I'm pretty sure you know, hey, when you are adjusting, you need not adjust every weight. Every weight, maybe one weight, or two weights, three weights, or here. It's like you have, if you do this, you have 13,000. If you take a simple neural networks like this, this is input and output. This is a two-layered network. When they say deep neural network, they talk about always input and output is fixed. They won't count that. I don't know, some people may count it. So it's a two-layered deep network. In this two-layered network with this many nodes, you have 13,000 weights. So you have 13, imagine those weights are like buttons, 13,000 buttons, 13,000 knobs. You need not change all 13,000 for every error. Maybe in one case you might have adjusted two weights, two buttons. It's 100. In some case, 1,000. Whatever it is you are changing, ultimately it should weigh. It should weigh. It's just typical balance. The balancing they change. You went to groceries. They put the groceries on the left side, right side. They start putting the weights. Oh, okay. Hey, the groceries are more. They start changing the weights. They're changing the weight. Okay, then again, still not bad. They're changing the weight. They're changing. Ultimately, it should balance. It should balance. So, how much you can change? You please see here. How much you can change? You have 13,000 buttons. Imagine you have another layer. You may have another 10K, 20,000 buttons. Imagine another layer. There are neural networks. There are 100 layers. Can you believe? 100 layers. They may have almost 500,000 weights. Can you imagine? 500,000 weights. So you can fine tune. You need not change just everything. Because you know the problem. When you are changing something, it may not work for something else. So that's why the change should be very fine-tuned change. That's why you need that deep layers. These deep layers will help you. The more deep layers, you will have the more weights, so you can have fine-tuning. You can have fine-tuning. So your network can be fine-tuned. When there is a fine-tuning, it means one change will not affect other change. That is what fine-tuning means. Fine-tuning means even in your work, you're changing something means you change it very modular. You know this has no impact. That's why they modularize your product software development process, so that the minimizes you change in one place doesn't affect on it. So here also, when you have so many deep neural networks, you can change such that it can recognize all images correctly. Not only all existing images, any new images that comes, it also recognizes. That is what our brain is doing. Our brain, if today you say, I can do things, what does it mean? I can do things means what? You are learning in the class. Or you're trying to understand your concepts. You are adjusting your weights. Hey, Harun, what is this? What is this Kafka topic? You're saying topic and splitting that server, this server. But what is happening? Can it read? Can two topics can be on two servers? Somebody is asking, Harun, I was hearing. That's a nice questions they're asking. Harun saying, no, topic is, you need to see it as topic. You write to your topic, you read to your topic high level. You need to see topic as high level. The topic can be split into multiple partitions, but only make sure you write it to one place. You write to topic, but you write to only one partition. So what is happening as you're asking questions, you are adjusting your brain's weight to understand this subject, this knowledge. You're adjusting your weights, your brain weight, so that you understanding this machine learning, this big data engineering, the Lambda architecture. You have the basics are very strong now for you. So that you, when you go to workplace also, these weights will help you to understand the things, to recognize, oh, okay, this is what I need to do, this is what I need to do. Here I have a hive, I need to write a batch job. Here I have a stream, data is flowing. So it is a stream process. Oh, Harun taught us how to read from Twitter. Okay, if I have a Twitter, my company is using Twitter, I'll pull the data from Twitter. But company also has a Kafka. Kafka is another source where you get a lot of data from other systems into Kafka. Then you'll be reading it. So you need a middleman. So that is where you're reading it. So all these concepts, your learning means nothing but you're adjusting your weights so that when you go to a new place, you can handle. So that is what the learning is all about means. Learning means finding the right weights and bias. So give the images, 1 image, 2 images, 3 images, 4 images, adjust them. Let me come here to another slide. Look here. So these are the inputs, these are the outputs. But for the training, you know it's error or not. What does it mean? I give a 9. I know this is 9. And if it is 8, I know it is error. So I'll adjust it. So training means what? Training means known images. You have inputs, the outputs have an error. So if there is an error means you need to go back and adjust the errors such that this error is minimum. Hema, is that correct? You should adjust such that this error is minimum. You should adjust such that
Yes,
if this is A7, 6, you should adjust such that this should become 9. You shouldn't adjust such that it become 1, no, right? You should go. So your adjustment should be to fix the error. So your error, you pass this error. So that adjustment technique is also available in the deep learning libraries. You may ask me, oh man, this is going to kill me. How can I adjust? You don't have to worry about it. So your inputs are image files. Your networks are nothing but functions. You may ask me how we build artificial neural networks. They are nothing but, it's a function. You see here, you're passing a weighted sum. Weighted sum, you pass it to a function, a software function. Like any software function you write, any Scala function or any Python function. And these functions interact. The function will have input and function will have output. The output of the function can be an input to another function. So somehow they are networked. And finally, that network has the feature of comparing the outputs. Comparing the outputs with the known value, because when I give 9, I know it is 9, but the output is different. It's not 9. So I know the error. Error means error between the value. Ideally, it should be 1. Ideally, output should be 1 for 9. But suppose I got 0.9, 0.8. The error is 0.2. So I know the error. I will adjust such that the error is minimized. I may not make it totally 1, but at least I can make it to 0.99 or 0.91. 0.9 is better than 0.6? Yes or no? Yes. It should be 1. It should be ideally it should be 1 for the output 9, the class 9, classification 9. The value is 1, should be 1, but I got the value 6. So, sorry, 0.6. So the error is 0.4. So my aim is I will be adjusting such that 0.6 becomes 0.7, 0.8, 0.9, 0.9, 0.6. After some time, you may not be able to adjust, but it's okay. So that is what, then that adjustment mechanism is already coded in the software libraries, those deep learning libraries. So that adjustment mechanism is called backpropagation. Please, can you say 1 or 2 times in your mind? Backpropagation. Can everyone say 1 or 2 times backpropagation? So we are sending back the error, back. Anyone knows what is propagation? Anyone knows what is propagation? Anyone heard about propagation? Propaganda. Nagesh? Kiran, you know what is propaganda, right? Spreading. Propagation. Propaganda. So, spreading rumors. But here it is not spreading rumors, spreading error. Backpropagate. Propaganda is a spreading. So, keeping mute, it's okay. You can't talk. Okay. So, backpropagation. Please, this is a buzzword. People use the word backpropagation. So, backpropagation, what if the error is passed back? Such that, see, the error gradient respect to the network's weight is calculated by propagating the error backwards through the network. Once the error gradient is calculated, the weight is adjusted. So when you, based on the, see, it means based on the error, you need to adjust. If it is too big, you need to adjust such that. If it is too small, you should adjust slowly. That's what gradient means. Gradient means the amount of changes you do. It's called gradient. Gradient. Rate. It's a rate at which you are changing. You should just change it. It's like, you know, can you change overnight? No. Can you go to, you are working in some skill now, you cannot become machine learning and artificial intelligence guy overnight. You are slowly learning it. You are making this concept get into your mind. And you slowly reach people, hey, to inform them you are in this skill. You start applying for jobs saying that, hey, I'm good at recommendations. I'm good at this. I know this concept. Slowly you move. You don't just jump it. So that's what it is. The error is backpropagated. This backpropagated operation is coded in those libraries. This backpropagation through which you adjust, the weights are adjusted. That is what the learning is means. Learning means. Deep learning means what? So deep learning means you have inputs, you have desired outputs. You have a deep layers, layer 1, layer 2, layer 3s. Deep layers. The learning means on the known images or known sounds or whatever it is. This network is learning from the input means you have errors. The errors are backpropagated and these weights are adjusted such that the error is minimized for all the training data. For all the training data. You have 1,000 images means each image might have error. Errors are adjusted. So if you have done the training on the 1,000, if your network can recognize the 1,000 images correctly, so automatically you can expect you can recognize the new images also. Is that a fair statement, Siva? Is that a fair statement? Somebody said training, right? Even you go to your learning, what you called driving test. You train yourself in the driving test. in US car driving. Then the road testing guy comes, okay, he does the testing. Oh, testing is good. I think he made a few mistakes only. Then he is good. He's good. So what is all learned or corrected is during training, how you drive, etc. Then you tested it. It's good. It's the same like this. Neural network is trained for the known images. Error is adjusted, just like our driving. Error is adjusted and tested in the test data. And it found it's decent. It's good. And the neural network is ready to recognize the new images, just like Shiva is ready for driving. So the learning, the idea of learning is deep learning, inputs and output, the deep neural network layers. The learning means adjusting or finding the right weights. When you adjust, finally you reach some weights. You may ask me how I know the numbers. So initially they might randomize to some weight. You can randomize some weights. Then as you are learning, you are adjusting. Finally, you get to know some right weights and right biases. It is like you want to put a radio. You are changing the channels. So nowadays you can speak to your remote, a radio or TV channel. What do? You first start some channel, then you start changing. Okay. Oh, this is CNN. This is my movie channel. Change it. Right? First you can randomly, you can have some weights, then you're training it, it's learning, you are changing the weights. Finally, your deep learning is over. You got the right weights and biases. Then your network is fine-tuned. Then this network is ready to recognize the images, recognize the voices, voice recognition. So that is what this neural network is all about. These concepts are coded in the deep learning libraries like TensorFlow. Google uses TensorFlow. That is more famous. There are few more libraries, but this is what most adopted. The Google TensorFlow is now put into the Spark. So the Spark put another layer so that it makes this TensorFlow easy. So all these ideas are coded in these libraries, like reading inputs, getting outputs, finding the error, back propagating the error, adjusting the weights, doing it one more time, doing it two more times, many more, many iterations until the errors are minimized. Once you have the right weights and right biases, your network is ready to recognize whether it is a panda or cat. Put this cat, it may say cat. If it is panda. If it is put lion. Because all lions are, it recognizes every lion, white lion, gray lion, some other lion, African lion. If your neural network is your autonomous car, it recognizes that this is a pedestrian, the traffic light, is some other vehicle, some other object, classification. So this is the idea behind artificial neural network, which is famous. Before we take the break, there are libraries for this. I'll talk about this. Last, I want to, before we take the break, the summary of our discussion. Mathematically, you can see it here. This was proposed by 1949, 1950, almost. 68 years back, almost 70 years back. But at the time, we don't have fast computers. That's why it was not too famous. It took almost 60 to 70 years with so much computing power, with so much data. These artificial neural networks became quite famous. They're coming from research labs to internet companies, from internet companies to enterprises, and soon to the society. That's why you knowing this knowledge, so powerful knowledge, is so valuable. That's what I encourage. So mathematically, can you see, Siva? Can you see this and summarize to our team? Mathematically.
So the x1, x2, x3 are the inputs, and W series from 1 to n are the weights.
Let's say this is output. Say this is
Okay.
J is J node. Let's say J node. Okay, this is Y, right? Output.
Yeah.
J node. So okay, this is J1 weight 1, right? This is 1 x1. So if this is J, so J1. This is J2.
J2.
Jn. If there are n. So these are weights, right?
Right.
So it is coming here. What is this sigma? Sigma is sum, right?
Yeah. Sum
Weighted.
of all the weights.
Weighted sum. Weighted sum. Look here. Yeah. Sigma means weight. Instead of writing a long symbol, you write a small symbol. Sigma means weight. Here, Ji, Xi. I is changing from 1 to n. It's okay if you don't not comfortable with these numbers. It's okay. Just understand. This is sum, weighted sum. Right?
Right.
See, they're passing some bias here. You see, some bias. This is bias. Look here, phi j, external bias. J is synaptic weights. Xj is input. Y is output. So this is the weighted sum. This is the bias. So it's ultimately a number. Coming to, what is this? It's a function. Here, this is a weighted sum and bias. This is passed to a softmax function. Remember the 1 by 1 plus. Why we pass it? So that if you pass this whole thing to this function, the output will be between 0 and 1.
Yeah.
Right, Siva?
Right. Right. Sir.
So these are the inputs. These are the synaptic weights. They call it weight or synaptic weights. This is weighted sum. And this is bias. They're adding bias. So this part, which is this whole thing, this is passed to a function, cell body in your brain, cell body, a limiting threshold function, this synaptic function. You get the output. So this document is 1949 document. I want everyone to appreciate this. See, the whole idea is summed up into one. If someone sees this, now after the discussion, you understand this. Can you imagine someone sees this before the discussion, they go crazy. They don't understand anything. Right, Siva?
Yes, Srini. Yeah.
Now, does that sums up here? Artificial neuron model, a professor by McCullough-Pitts, model 1949. These are the inputs, these are the weights, and this is bias here written here. These are the inputs, Y is an output. These are the synaptic weights, this is bias. Sigma is sum. Finding and the strength of the existing signal are controlled by activation function. Strength of the signal, they talk this in terms of signals. Signals means basically weight. Signal strength means weights. Controlled by activation function. The types of activation function. The output value between 0 and 1, these functions can be different also. We are using one type of function. So linear function, step function, ramp function, sigmoid function, we are using sigmoid function. Hyperbolic function, Gaussian function. Different people will use different functions depending on their experiments. But overall, another model, product unit, allow higher order combination of input, having the advantage of increased information capacity. It's okay, don't worry about it. That sums up the theory and the concepts behind the deep neural network. So go back to our slides. Now I'll share those slides to you. What you learned today before taking break is you understood the neurons. You understood basic neural network with one layer. You understood what are the weights and this one. You understood what is the sigmoid function, how it can take any input and give output between 0 and 1. Also same. This is how a grayscale image of a handwritten digit, 28 by 28 pixels. For that matter, you can have any number of pixels. This is the input, output is this desired. These are the categories, 0 and 1. These are not values, please note. Hema, Leela, Nagesh. These are the classes, 0 class, 1 class, 2 class. The values will be the output value that comes, always between 0 and 1, you know. These are used for image classification problems. This is in both letter and number slide. I'm just showing it to you so that the slides are useful to you. So these are the inputs. This is representation of weights for one neuron. This is second neuron. Now Nagesh and Mukesh, you know now each neuron will have its own weights. This is weighted sum. This whole thing can be written as sigma. That is what sigma means. So learning means adjusting these weights. The back propagation. This is what is shown. Inputs comes, outputs, there will be an error during the training. The error is back propagated and weights are adjusted, with which ultimately we can able to recognize, classify. This is a classification, multi-classification problem. This also can be used for binary classification also. To support this, there are softwares called TensorFlow. This TensorFlow has another layer called Keras. Keras uses TensorFlow. Please note, these are not independent softwares. TensorFlow is a software on which there is a simplified abstraction layer, Keras. So Keras works with TensorFlow. In Spark, of course, TensorFlow and Keras are on Python bindings. So in Spark, we have Spark with Scala, Spark with Python also. So PySpark is called PySpark. So PySpark works on top of this TensorFlow or Keras. Sometimes Keras is not used. Python can directly work on TensorFlow. Some people use Python on PySpark on Keras, because anyway Keras works on this. So this combination. So these libraries are called deep learning pipelines. Deep learning pipelines for Apache Spark. So this is being adopted in the enterprise nowadays. Any decent basic understanding will help you. You don't have to be an expert in it. Any decent understanding will help you. But you shouldn't compromise on machine learning. Become strong in machine learning, understand these concepts. These are very important concepts. Now you understood. I'm pretty sure you got the idea. So that sums up this slide. Now this slide is optional. Now you really don't need. This is also weighted sum to find. No, I skipped this. I don't want to get bore you. So we'll talk about this. So these techniques are used for complex classification issues, especially where you want to classify these blood cells, cancer cells, and regular cells. The separation has to be very complicated routing. So that's why these deep learning concepts are important. And the process remains the same. You need to get the data, clean and prepare the data, train and test data, and improve. Any questions right now before we take the break? How does it sound, Hema? Does that give more clarity? I know you might have caught it before.
Yes, Srini, it's very clear.
You can able to articulate for others, right?
Yes.
Yeah. Okay. Kiran, how does it sound?
Sounds good, Srini.
Okay, some additional clarity, right?
Needed. I mean, yeah, whatever you explained, it was very well. When you did a recap, it was good.
Very
Just
good.
practice needed at our own end.
To adjust your weights, right? The brain. Right, excellent. Anyway, it's in recording. Mukesh Nagesh. How does it sound, the theory part, before we go to take a break and start seeing some software related stuff?
Yeah, looks like a good start, Srini. I'm able to understand something.
Excellent, excellent. Siva, I'm counting on you to give a session on this in the coming weeks.
Yes, Srini, this sounds really clear theoretically. Yeah.
Very good, very good. Surya and Leela, does it give you some idea, some good start?
Yeah, Srini, I mean, it was good. I mean, able to understand.
Okay. I know it's not only you go and talk to anyone. You spend days and days to understand. I've been meditating how to make it clear for you. So that's where I have to adjust my own weights to make you understand. Leela, how does it sound? You're on mute. Okay, that's okay. So, okay, this is 10 o'clock. We started at 8. Time passes very quickly. Already 10. Let's take 15 minutes break. It's 10:05. Take 15 minutes break. Even I need to quickly grab some breakfast. We'll meet at 10:20. Then we'll close it by 8 o'clock. Sorry, 11 o'clock. Hi everyone, welcome back. Let me see if you can hear me. Narayana, can you hear me? Siva, can you hear me? Hello, anyone can hear me?
Yes, Srini.
Okay, thanks. Let me share my desktop. Okay. Okay, let us spend some 30-40 minutes without crossing 11 o'clock. I am going to help you to set up some environment. Even the cloud is not fully supported out of the box. We need to adjust few, or rather we need to add some libraries. So let me share a few links so that we'll go and add some libraries to our cloud so that your system will be ready for deep learning problems. Then I'll touch base on Python and give some assignments for you this week so that when you come back next week, we'll be in a position to write some programs. Let me see. First, this is not related to deep learning. This is related to big data engineering Harun is doing. There is one course by Databricks. I found this is good to brush up your existing knowledge. It's called Getting Started with Apache Spark SQL. So can everyone, I will show you how to import this into your Databricks environment. So everyone, please let us spend some 10 minutes. Go to this, log into your this Databricks environment. Can you open up everyone open up this link? Sharing to everyone. So go to this link. So just say click the start the course. So they'll ask your name. Put some name. Whatever it is. Say something, list of data scientists or something. Just say click. Submit this. And click this submit. Then you will get a notebook with the whole thing. So after that, you click this import notebook. It will give you an URL. Can you do that? And let me see if I can pass this to you without you doing multiple registrations. Let me see. Can everyone have this link? Okay, take this link take this link, go to your Databricks environment. I put in your chart, go to any environment. Just to click home. You can create some folder. Create a folder saying that big data, just say training or something. It will create a folder. Here again, click this, create folder. You get a folder. Then click this, right click this. This time there is a link called import. So basically you are importing that whole training course into your Databricks environment. That way you can go and see the training. So that it helps you to consolidate, your knowledge. So click import. This import will give you a URL. Paste that URL I shared to you. Simple. You create a folder. In this folder, try to import this particular URL. Once you click import, you get this. Basically, you have this import. This is a training course which help you learn a lot of stuff. So after you've done the step, you need to do one more import. Let me again go back to that big data training. Again import. So let me give you, I'll share this URL also. This import. Then it creates a folder which gives you many notebooks which has all the details like how you query SQL files, some sample data, sample code. I want you to practice this so that you will be very comfortable. Let me share you this URL also. Share you basically two URLs. You create a folder, import these two URLs into Databricks.
How to create folder?
Go click this in the workspace. Click any home, workplace, create a folder. Create a folder.
Okay, got it.
Then go to that folder, right click, import. So I gave you two URLs, import them. If you have done that, can you put a message that you have done? Emma, are we good? Narayana says he is done. So as I told you, this has a course which can help you to consolidate all your big data engineering knowledge, how to get started with Databricks, how to query files, how to create data frames. It has video, you can select data, you can describe.
No, we didn't. Yes, Srini, we are good.
We're good, right? So probably, yeah, in this, you have many things. How you join tables, how you access JSON files, how you access data lakes. certain project is there, some additional stuff is there. They little bit organized very well. So that would help you. You have learned a lot of stuff discussing in the class with Harun and with all of us. So at one place, they did a very good job giving people how to access Parquet files, how to use this whole cloud. That's good. So Hema, if someone calls you, please help them on this matter. Okay?
Sure,
Or
sir.
sometime in the class, maybe you can, if someone needs, we will demo this.
Okay.
So I encourage you to do this, practice this to consolidate your knowledge next 2 weeks. Spend next 2 weeks, spend some time, maybe weekly 2 hours. You don't need more than that. Okay, that's good. Let's go to next. Next is I want you to open your Databricks. I want you to prepare your Databricks environment for deep learning. So for that, someone I want you to share your desktop so that I'll show you. Hema, can you, do you have an option to share? Do you think you can? Hema?
You want me to share my Databricks screen?
Yeah, so let me stop this.
Okay.
I share, take it and you share so that we'll show them. So show out to everyone. You should start doing it in the class right now as Emma is going to demonstrate. So basically you are preparing your Databricks environment for deep learning. So you need to import some libraries, you need to do some stuff before you do this.
Yes, Srini.
Okay, give me 1 second. So let me share you this, keep as a reference. Give me 1 second. Let me. Okay, where should I share? Okay, chart is here. Very good. So I shared a link to everyone. Everyone has to open. Hema is also going to open this and show. So this has a steps how you prepare your Databricks environment for deep learning. You need some libraries to install into your cloud. So how to import those libraries? That information is here. So one side this tab and another is your Databricks environment. Okay, so I shared this link to everyone in the chat. Please open it. So if you see cluster setup, this is the basically first before we're doing Hema, we just highlight what all the things we need to do. It has steps. First is a deep learning pipe. Can you start reading it slowly? You can move this left side.
Okay.
Can you read once and?
Yeah. Introducing deep learning pipelines for Apache Spark.
Let us go to the cluster setup directly.
Okay.
Yeah, please.
Deep learning pipelines is available as a Spark package. To use it on your cluster, create a new library with source option, Maven coordinate, using search Spark packages and Maven Central to find Spark deep learning. Then attach the library to the cluster. To run this notebook also, create and attach the following libraries via PyPI, TensorFlow, Keras, H5Py, via Spark packages, Tensor frames. So are we going to do Spark packages now, Srini?
Yeah, so first let us do the Spark deep learning, right? In the above, before in that same cluster setup. They said first you need to create Spark Deep Learning.
Yeah, create a new library with the source option,
Maven coordinate
using search Spark packages and Maven Central.
To find
Spark Deep Learning.
Copy that Spark Deep Learning. Yeah, cool. So we'll install this first. So basically, now we are going to show you how to install some libraries in the Databricks platform. You can do libraries, mean any external libraries, either Spark packages or Python libraries, they call PyPy libraries, or any jars, Java related jars, any external libraries. So Emma has copied that, and she's going to show you how to create libraries. So go to home button. Okay, home button. Again, click home button. Go to shared. There is a shared folder. Everyone can click shared folder. Everyone can click shared folder. Okay. Yeah. Create library. Create library in the shared. Then you see this. You can create Java libraries. What are the options we have, Hema? We have
source, library name, and jar file here.
So can you drop down that? Yeah. See here, PyPy libraries and Maven coordinates also. Can you show again to the team? That list, yeah. R libraries we don't use anyway. Maven, PyPy, and either Scala libraries. So Hema is going to use Maven coordinates. So Maven coordinates, based on Maven coordinates, it comes from the Maven Central. Yeah, can you search for that? You copy that, you paste it, right? Choose the Maven coordinate, paste that, whatever you copied, Spark Deep Learning, search for that, click that search package. It doesn't show up, then paste here also. Sometimes paste here and search for that. Deep Learning libraries. Paste that. Check right side instead of Spark packages. Choose Maven Central. Yeah. Okay, paste that. Now click that. Let it come. It's taking time. Everyone, search that. Search Spark packages. Put that option Maven Central right side, and search for that library.
It's still not done, right? It's still saying searching.
Still searching, right?
Yeah.
Let's see.
Right. Using search Spark packages and Maven Central is it? I don't know how we can search with both. We select.
Go back once you close it first. Try it.
No, this is not working.
Search for Maven Central. It should come. Anyone got this?
Yes, but I got under Spark, not Maven Central.
Oh, under Spark packages?
Mm-hmm.
Okay. So can you close this once, Hema?
Log off and log in again.
Just close it.
Okay.
Search packages and Maven Central. That's what. That again. Click that. Oh, okay. Got it. Okay.
Okay.
So, yeah.
Which version?
Choose the first version. Yes. Yeah. Select. Create library. Create library. Can everyone do that, please? Search for that. See that created. What it created, if you see. Can you read that, Hema? It automatically attached.
It downloaded some artifacts like Scalistic 2.11.11-300, TensorFlow, Commons Proxy, Commons Lang, Scala Logging, Scala Logging API, SL4J, SL4J API, Spark Deep Learning, Spark Support, Tensor Frames, Library TensorFlow, JNI, Library TensorFlow jar 1.6.0.
It also says option automatically attach automatically to all clusters.
Yeah.
So you are good with this first step, step number 1. Can everyone, anyone has done that? Siva says he has done that. Kiran has done that. Narendra has done that. Very good. Leela, that's good. That's good. Excellent. Good job, guys. Go back. Now go to the documentation, Hema. So yeah, now you can close this, go back. In the documentation, what is the first one is done. Next is create and attach the following libraries. What is that? PyPy. Through PyPy, you need to install TensorFlow, Keras, and H5Py.
H5Py, yeah.
Go take one by one. Now go back again, shared. Go to shared again. Again, create library. Right click, create library. This time choose, go slowly, Emma. Can you show again? Click slowly because so that others follow. Python egg or PyPy library, PyPy. That's good. PyPy library. You search that TensorFlow. PyPy. Let us use TensorFlow. I think they may not come.
Same thing. Same. Spark Deep Learning.
No, not that. Right. Next, that is already over.
Okay.
Next one is TensorFlow. First TensorFlow, next Keras, next H5Py.
But we already got TensorFlow.
But that one Scala related, this one Python related.
Okay. Shall I click install?
Install library. Yeah, PyPy rules came.
Rules are there.
So you're good. That library. So whatever you're installing, they are appearing there, you see. Next you will install again PyPy. This thing Keras. Keras library. Very good. Yeah, Keras also. Okay, rules.
H5Py.
Some library. Supporting library.
Got it.
Good.
Yeah.
Next, one more is there. Actually, that might have come already as part of Spark Deep Learning Library, which is Tensor Frames.
It's there.
But I don't know why they asked to install again. Let us try to install directly. This time Spark packages.
Okay.
Shared, right click, create library. The Spark packages. Just leave. Just say my own coordinates. Click that. Click anything. Put there Tensor Frames. Tensor Frame. Use the top one, Databricks one. Use the select option. Right side. Click select. Create library. It's also came TensorFlow.
I think it's again same thing.
It's okay. Now, can you show to the team what all you installed? It shows to you there shared. PyPy one's already there, right?
Yeah. First, we installed Spark Deep Learning using Spark package, search Spark packages and Maven Central. Then we installed TensorFlow, Keras, and H5Py using PyPy upload. We created these libraries. Then we searched for library Tensor Frames and downloaded, means attached all these libraries to our cluster automatically once we download it.
Good job, Hema. So I hope everyone has done that. That's good. Yeah, most of them are said yes. That's good. Thanks, Hema. You can give it to me. Okay, so your cluster is good, but there could be some issues also as you do it, because these are external. Till now, you're working with standalone, where everything is working, but since you're using other libraries, there could be version issues. Hema, can you share your experience working with multiple libraries to our team? Do you get some issues, versions, differences? Then what are the things you do in your work?
When we get the differences in the library versions, yeah, usually we'll try to use the latest version. If that is not working, we will like make sure like which version is supported by current base version.
So you are saying getting some issues is normal, right? When we are using library.
Right.
Yeah, so we encourage people not to get panic if some issues comes. We can work with forums and get resolved. Okay, that's good. Yeah, can you?
Shall I hand it over to you now?
Yeah, please, yeah. Sorry.
Srini?
Yeah, can you? Sorry, can you? Hello?
I'll just stop sharing, okay?
Yeah, please. Okay, thanks. Yeah, that's good. So we've done two things. One is big data engineering related course. You have got into a folder where you can start preparing, consolidate your knowledge. Then you, under shared, you could able to install some libraries that is needed for deployment. So next is, as I highlighted, these you have seen when you are installing also, it uses TensorFlow. TensorFlow is a deep learning library from Google. So they are very powerful libraries. So that is where now a lot of industry started using it. But TensorFlow is very low level libraries. Low level libraries means you need to do a lot of stuff. So that is where there is another team in the Google itself. They created a wrapper called Keras. So Keras is an abstraction or wrapper around TensorFlow, which take this TensorFlow into a little bit high level so that you can write these programs a little bit easily. So what this Apache Spark team has done is they wrote another abstraction so that they made it more easy, so that it is available to enterprises. Because till now research, artificial intelligence is more, especially the deep learning, it is more used in researchers in universities and internet companies like Yahoo, Google, or some Amazon and Apple and Microsoft, Facebook, different companies. Now enterprise start adopting this. So they have a lot of challenges to understand these concepts. These are not pure theory. There's a lot of experimentation is there, a lot of empirical outcomes and lessons are there. So that is where there are a lot of challenges to get the talent. Not only to get the talent, to use these libraries, there are a lot of challenges. So that's where the industry is going for more high-level abstraction to see how to simplify as much as possible. So that is where now there is a lot of development going on in the Apache Spark, which is leading enterprise big data and machine learning libraries for the big data. Because nowadays the data is growing and a lot of big data is there. So how you parallelly run this machine learning on the big data is the strength of Apache Spark. So that is where even enterprises want to run deep learning in parallel loads in a big data. Sorry. So this library is called Deep Learning Pipelines for Apache Spark. So those are the things you have installed. So those packages you search, then you install TensorFlow, you install Keras, and Python libraries. Now all this works in Python. It doesn't work on Scala because under the hood it is TensorFlow, which is on Python. It can run on Scala, but right now they are available purely on Python. So that is where you need to learn PySpark. You already know Spark on Scala. Now I'm going to introduce to you PySpark. PySpark is not difficult, especially when you know Spark with Scala. It is in similar lines, but still you need to be mindful of how you are doing it. I want you to learn this as you do this. And also next 2 weeks, spend some time weekly. 2 hours in coming week, next week 2 hours. Totally 4 hours you spend on basic Python and some assignments I'll give you. So brush up and get comfortable. You don't have to be expert in Python. Any language, once you know one language, any language you can easily learn. They follow in the similar lines. But still, certain syntax will be slightly different. So there are a few things you need to be mindful. So that's what I'm going to do next 10-15 minutes. We already have 10:50, so I'll take maximum 5 more minutes. In the sense, 11:05 we'll discuss. So next 15 minutes. I'll introduce to you Python, PySpark. Then I'll give you some assignments so that you'll be ready for next class to write these deep learning programs. Okay. For that, you will be going to your, let me see, let me use maybe, I'm going to give you this as assignment anyway. So, okay, see, this is when you create a Python notebooks, you create a notebook here, till now you are writing a Scala here, you can use Python, then you can name it. So that way you get your Python notebook. So where you can write your Python programs directly. So your Python programs are simple. See, in Scala, if you see, interesting about this notebook is if I put %Scala, it assumes I'm writing Scala. So look here, if I say val name is equal to Siva, then I run this because it's getting connected to my cluster. So it runs the Scala program. So if you write %sh, it runs shell program. If you say %Python, it runs the Python. But since this is already a Python notebook, you don't have to say anything. So by default, if you don't say anything, it means you treat it as a Python. So in a Python, to declare variables, you don't have to mention val. So you don't have to mention val or var or anything. You just declare it. Like say name is equal to Siva. You can simply say name is equal to So you don't have to declare. See how close they are related. I don't know why it's taking a lot of time. Let me maybe create another one. This is a Python. Just a Python. Python Smart. Okay, just put it. Because here also I need to, okay. I don't say val, I say name is equal to, or let me say A is equal to 2, B is equal to 3, A plus B, A plus print, A plus B. Launching this one, it takes this a few seconds, maybe 50 seconds or a minute. So you can write the Python like this, general declaration. The functions in Scala, you define a function to define add, you mention two variables x as integer, b integer, then finally you'll be writing something like a plus b. That's how you declare. So in Python also you use the word def, but you won't mention the data types. Python is not a compiled language. It is a scripting. Scala also appears like a scripting, but when you run it behind the scene, it compiles into Java. So it is a statically typed. Typed means the types are very important in Java and Scala. But in Python, the interpretation. Interpretation means it doesn't compile. When it is running, it dynamically compiles. So you will not mention the types. Okay. That's why there could be some issues with Python compared to what you call Scala and Java. But it is very much used by industry. Okay, this is done. So why is it print? Then it's a print line. Let me see. Okay, it's already printed, sorry. 5. So def is, you define like this. See, in Python, you need to use the semicolon after your this one. Then you say this one, print A plus B. Putting here. So if I come here, I declare a function. It doesn't tell you a declare, etc. The Scala, whereas Scala gives you, hey, this function is created, etc. So I go back. Now if I say add of 4, 5, see, got 9. You see? You see this, Siva? Do you see? So it goes in a similar line like the Scala. So it is not much complicated actually. So originally there was a Java and enterprises use, but a lot of universities and communities use Python. So the Scala has the best of this Java and Python. So the Python like syntax is there in the Scala. So and at the same time it has the benefits of Java, which is a statically typed, which is a compiled. So when you're running on the clusters, especially on the multi-threading environment, the Scala is very powerful and safe. Okay, so here but since the deep learning libraries mostly are there on the Python, Python is the de facto standards for the deep learning. So, but Spark supports both Scala and Python, of course Java also. So Scala and Python. So it really helps when you are going to industry also, even just for big data engineering and machine learning itself. Hey, I know Scala, that's really good. I also know Python really adds value, because in some companies, they might use Python. Usually people use both Scala and Python. But some people might use just Python. So you can easily catch up. So having this Scala, learning PySpark, I don't say you'll become expert in Python, but it's a PySpark. You learn the PySpark to do PySpark jobs, Spark related Python. It takes, a couple of weeks, not more than 1 or 2 weeks if you can focus on it. That's good. So I encourage you to learn this as we do it so that you easily understand. So first, I want to give you one assignment to you, which is, let me, PySpark anomaly disk. Okay. You remember we done anomaly detection, Siva, Narayana, Hari is in travel to Dubai. So we did what he called a anomaly detection in the Scala. You remember last time? Narayana, is that correct?
Yes.
Okay, Narayana. So here, so the whole thing we did that is now I have rewritten in a Python. Whatever you have the program, I have rewritten in Python. I quickly walk you through. Please run this next week when you're coming. Go through it a little bit so you understand. See here, the way libraries are imported, see here, you just don't say import. You can say import NumPy as NP from Python libraries, import this. A slightly different syntax, please observe. But again, it's the same, importing the libraries. See here, you can read it, Spark context, you can read the text files, the training data. In Scala, we'll be writing like this, val, that's it. How beautiful it is, you see? See, is it? Just like in Scala Spark, you can take these 10 number of rows, etc. It shows some weird outputs. For strings, you put some colons, all those things. Don't worry about it. So if you want to know the type of it, it doesn't display the type quickly. It shows the type. If you say type, it will tell you, hey, what is this variable type? Variable type is RDD, something like. So by default, it doesn't share it. It knows it. It is either integer or text. Because the integer, if it is a number, which is not put in a quote, it says integer. If it is a text, if you put it in the double quote, it knows it as a string, just like a Scala. But it doesn't tell you. It doesn't display this one. So then you remember you split the data when you have a RDD, it's the RDD of string, you split it, then you convert it into dense vectors, all those things. Here you see, when you do in Scala, I'm comparing that because you know that. See, when you have a raw train data, suppose you mention val raw train array. How you do it? You take this and you do map. You take a line. You arrow. You say line dot split. Is that correct, Narayana? Is that correct? If it is a split, is that correct?
Correct.
Yeah. In Python, see here, Python syntax, in PySpark, you'll write like this. Please note here, you will not mention this. Remember this. This is the same. It also has a map functions, higher order functions. In Python, they are called lambda functions. So before you put the line here, you need to use the word called lambda because that shows it is a lambda function. A lambda function is like a higher order function. You don't have to mention for each, or you don't have to mention the whole logic. It means it does for every function, every element of it. So it means it's you need to mention lambda for higher order functions, map, filter, all those things. It's the lambda. What it is doing, lambda means just like this. You are mentioning for each, for every line. Instead of rocket, you need to use this column. Then it's the same. Please see how beautiful it is. Maybe here and there, instead of double quote, you use single quote. Those things, as you start running, you'll come to know. Okay, after you split, what happens? You get an array. So in Scala, you write like this. Next step, what you do is you say val train data. You take this raw train array and map. In Scala, you will say each array element, you use Racket. You pass that each element, array element of, instead of square bracket, you will use small bracket. The first element, 0. Is that correct, Narayana?
Correct.
So you take this as this one. So for first element, second element, from this array, you pass it to a vector.dense, which is a dense vector. You are making a dense vector. You will have array, so you'll get the train data like that. But in PySpark, it's very simple. As I mentioned, you will have there will not be any val concept. You just have to mention as is. See how close they are syntax map. Just you have to mention this. You have to remember. Python always you have to say when you are writing higher order function, it's a lambda. Lambda, whatever this is, instead of bracket you will be using colon. Even for functions you will be using colons. I told you. Even for functions you need to use colon. That is the main difference. So with that observation, you please start running this. It's the same. How you map it, then you display it. Also, if you want to print you have for each in Scala, some RDD dot take 5 for each. So those things you might have to write is for syntax. For X in this, you are taking 4 elements. See here, Narayana, you are taking from this RDD, you are taking 4 elements. You are looping it. How you loop it? For X in, you need to use for X in. Like that, few syntactic sugar is there. I think you can able to capture. So this is a good exercise because you have this in the Scala. If someone doesn't have, Narayana, can you post it on Facebook? Earlier, the Scala notebook I had shared to everyone because you are focusing on the anomaly detection. You have the Scala notebook, right, Narayana?
Yep.
Can you post on Facebook the Scala version?
Sure.
So I will post this Python version. Please try to run that. Please try to run this also, just to compare the syntax. So it will save a lot of time for me. If I just start teaching very basic things, it will take a lot of time. So instead, it's very simple. Take that Scala, this one, and compare this with this. You can understand the fine difference. The only thing is, first observe this. There is no vals or vars, so you declare this variable as is. All higher order functions works here. Instead of Racket, you use colon and use the lambda is the word. If you want to do a loops, use the for loops and other things with this syntax so that you can print. Then here and there, a slight syntax is different. Find out what are those minute differences. Just comparing this with the working Scala and the working Python. So I'll share this and post it onto the Facebook. Prepare and come back so that next week we can able to deploy pipelines. Anyone has done some Python? Hema, you done some coding, right? On Python?
Srini,
yeah.
I did Python in my last job.
Yeah. How did you compare to Scala? Is it a little bit close? Is it difficult to learn for our team?
No. It should be easy. So we need to understand the differences with the data structures with the Python and Scala. There is one difference, dictionary and that. Other than that, this coding should be pretty easy.
Wonderful. So, Nagesh, do you think if someone reaches, you can help them on the forums or anything?
Yeah, I will. Next week I'll be getting free. I'll see if I can take next Sunday little bit on Python, comparing that
That
with
is awesome.
Scala?
Just spend just 30-40 minutes. You don't need a lot of time.
Okay.
Excellent. Thanks for Nagesh. Okay, anyone has any questions? Does it sound good? Get ready for next week or see something on YouTube. Or this is good. If you compare this to a full-length program, Scala program, you have everything here. Almost how you display, how you write a function, how you write a, what you call, even for running multiple in ranges, how you do in Scala, how you do here, how you declare a function. Everything is there actually. If I want you to run this, understand this. That way you'll be ready next week for the deep learning pipeline. Also, I'll make sure friend discuss with you guys. Okay, guys, how does this? Any question? What is that? Hello? I didn't hear. Kiran, Leela, how does this sound? Sounds good? Mukesh?
Yes, Srini.
Okay. Siva?
Yes, Srini, this was a great session.
Okay, wonderful. Surya?
Yeah, good, Srini. It was good. Yeah.
So, Hema, are we good? Kiran? For today?
Yes, Srini, thank you. Yes.
Okay, wonderful. Narayan Rao, Harun, Leela, everyone, Nagesh, good joining, all of you. Let's connect tomorrow. Harun will be engaging and Siva will be connecting on the customer churn with the logistic regression. Siva team, you can call me sometime in the evening. We can spend 30 minutes if you need. I can share any issues. Okay. Good guys. Yeah, you have a good day, rest of the day, and let's meet tomorrow. Okay. We're done for today. Thank you.
Thank you.
Thank you. Sure.
Thank you, Srini.
Bye all.